Hello and welcome to today's edition of, I guess you missed science class. I wish you were here. But today we are doing Station 5, which is man-made ground cover. And what we are going to do is we're going to pour water over several man-made surfaces like bricks and roofing shingles. And we are also going to use concrete to see how much infiltration that we have. So basically we're going to start with the brick and we'll go to the shingle and then we'll move on to concrete. But before we do anything, you want to make sure that you write your prediction down right here. How will water move over man-made surfaces? We've been looking primarily at natural surfaces and different elevations. Now we're going to take a look at some man-made materials. So we have a concrete brick, we have our roofing shingle, and then we have concrete. So we're going to start with the brick. So we have the brick elevated at one end, and we are going to pour 200 milliliters of water on the brick and measure the amount of runoff. So I will start. I'm going to pour 200 milliliters across that brick. Now you're going to need to draw a model of what you see, so make sure you're noting how that water is moving. Okay, here we go. So I'm going to move the brick and we will measure the amount of water left over. So we started with 200. And we have about 200 milliliters left. So we had no water infiltrating. We had all of that 200 milliliters running off. So now we're going to do the same thing with a shingle. This is the same type of material that you would have on your roof. So again, we're going to take 200 milliliters, pour it onto the shingle. Make sure you're noticing how the water moves, making those observations. There goes our 200 milliliters. And we will measure how much runoff we had. Go. And we had, again, about 200 milliliters left. So we're not getting much infiltration on those surfaces, rather we're getting all of that water running off. Now for the concrete, we have a column just like we had with the soil column. Get that pan out of the way. So we'll put that there. Now I'm going to pour 100 milliliters onto the surface, and we're going to see if we can get any infiltration on the concrete. Well, we're not getting any water moving through. We just have the water sitting on the top. It's not really moving, so let's measure. And again, 100 milliliters of water left, so none of that water infiltrated. Back in your lab packet, make sure that in this space right here you are drawing a model of those three things that we just saw. So you're going to draw what it looked like on the brick, what it looked like on the shingle, and what it looked like on the concrete. Make sure that you have the measurements as far as how much water infiltrated or ran off, because that is going to help us out for later. And then the last thing that we are going to do, and I know this is probably appearing backwards for you because I don't know how to switch the camera midstream to the other way, so sorry, not a tech wizard. But we recorded in a data table the class averages of the amount of runoff and the amount of infiltration. So if you need this, you can print that off of Classroom. And then you can record that. In the green column there, you're recording the runoff from your labs, and again, that's all in your packet. And in the orange column there, that is the infiltration. So basically, you take your start amount, subtract the runoff, and then that will give you the amount of infiltration. So sorry about my headband, but I'm pumpkin spice today because it's internet meme day or something for Spirit Week, so sorry. There you go. If you have any questions, let me know when you get back.